Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. D Mohanty and today we will discuss enthalpy. Enthalpy is denoted by a letter capital H, and enthalpy is defined as the sum of internal energy plus pressure volume product. And enthalpy is an intensive property. So first we'll discuss the internal energy and then the pressure volume product. While discussing the internal energy, I have told you that internal energy is actually the summation of all the microscopic energy, and the internal energy denoted by letter U, H, N times epsilon, where epsilon actually represents the microscopic energies. It includes the energy due to translation, energy due to rotation, energy due to vibration, then chemical energy, electronic energy and nuclear energy. When it comes to your PV, what is that PV and what is the significance of PV, that we'll discuss. PV is actually the amount of energy required to give physical dimension to the substance. All of us know that at absolute zero temperature, the volume of any substance is zero. Although till now the absolute zero temperature has not been attained, but the volume is significantly reduced even we reach temperature close to absolute zero. So from zero volume to have some volume, we need to do some amount of work, and that is nothing but your PV. So now the enthalpy is split up into two parts. One is internal energy, the second one is your pressure volume product. As I have already told you that internal energy is sum of all microscopic energies, and PV is actually the amount of energy required to give physical dimension to the system. Now the enthalpy is usually not being represented by capital H, always we use the term small h, which represents the specific enthalpy, and specific enthalpy may be represented like this. This is small u plus small p into V. Now if you take differential of this, you get dH is equal to du plus d of PV. This implies dH is equal to du plus pdV plus vdt. So this is the expression for change of enthalpy. Now in most of the cases it is observed that the pressure remains constant. So when pressure remains constant, this expression reduces to dH is equal to du plus pdV. There are some cases where even volume remains constant. So here pressure is constant. When volume remains constant, this reduces to dH is equal to here volume remains constant. And there may be cases where both volume as well as pressure may vary. In that case, this expression will hold good. you can denote this as equation 2, and these two are actually the corollaries of equation 1, both equation 2 and equation 3. Now, what is the heat transfer at constant pressure? Heat transfer at constant pressure is du plus PdV. This involves the change in internal energy plus the displacement work, which is also known as your PdV work. You may denote this as equation 4. Now, when pressure remains constant, your enthalpy is du plus PdV. So from this we conclude that del Q at constant pressure is nothing but your dH. That is, the heat supplied is equal to the change of enthalpy at constant pressure. So this is a very, very important expression for all of us. Another thing that you should remember, that just like your internal energy, the enthalpy is also represented as change in enthalpy. You cannot find out the enthalpy at a particular point. That is not required also. The change of enthalpy will do. What is the reason for this? Because you know that enthalpy consists of internal energy as well as the pressure volume product. So as far as internal energy is concerned, you cannot find out the internal energy at a particular point, because the energies are the summation of different microscopic energies, and it is not practically feasible to calculate that. So when that part cannot be calculated, you cannot find out the enthalpy at a particular point. So always enthalpy is represented as change in enthalpy. Suppose you have 2 points and you may say that it is H1 minus H2, or if you are considering specific enthalpy, that is enthalpy per unit mass, it is H1 minus H2. Now, the major confusion that people do not understand, that while calculating the enthalpy, we have to take a reference point, and at that reference point the enthalpy may be assumed to be 0. Now, if that is done, then there will be no problem in calculating the difference in enthalpy. Usually the reference point taken is 25 degrees Celsius, that is equal to 298.15 Kelvin. Some of the researchers, they do take reference point at 0 degrees Celsius, that is 273.15 Kelvin. Now, once you take this as a reference, then you can easily compute the change in enthalpy, whatever may be the value, whether you consider 0 or this one. Suppose in the number scale, 0 is considered as minus 2. So what happens to 1? 1 becomes minus 1. 2 becomes 0. But the difference will always be 2, because 2 minus 0 is 2, 0 minus 2 is also 2. So there is no problem. So you should understand that when the values of enthalpies are given, whether it is refrigeration table, whether it is steam table, in all the cases a reference point is chosen, and that reference point, the enthalpy is assumed to be 0, but nobody can find out the absolute enthalpy. So always it is expressed as change in enthalpy, and already I have told you that it is a state property and an intensity property. So I sincerely believe that this class on enthalpy would be extremely useful for all of you in understanding the concept of enthalpy. Thank you all for watching this video. If you have any doubt, you may put the questions so that I will try to answer the same. Hope to see you for another lecture in my YouTube channel Erudispace soon.